Okay. It's the most exciting part. All right. Oh, towards the end of class, we're going to head out and do a little quick field trip. We're going to go through the tech mall. I'm going to show you where the tutoring centers are, and then we're going to end up my office, which is kind of nice for me because that's where I want to be anyway. You'll probably be on the other side of campus from your car, but you'll get over it. You get over everything. You can bounce back. So, like I said, we did section 1-3 stuff. That was the nominal, ordinal, interval, ratio stuff. Cool. That we did last time. I kind of skipped over, because I'm used to it coming after that anyway, the types of sampling. So just a real quick little review. What level, nominal, ordinal, interval, ratio. What level would these be? What level would birth year, the year that you're born, what level would that be at? Interval. I love it. Why? You can subtract them. That's the most you can do. Now, I really want you to understand, you tell me the highest level is at, because it's also nominal. Right? I could say that's that 1985 movie. It's the name of the movie. It's part of the name. It's a way of identifying it. So everything that's ratio is also all of these. Everything that's interval is also these. So forth. Ordinal is just nominal data that has order. Interval is just ordinal data that can be subtracted. You guys get the feel for that? So you always tell me the highest level. Don't tell me a bunch of stuff. Tell me one thing. So birth year is definitely interval because division doesn't make sense. Right? You can do it. It just doesn't make sense. So interval. I like it. What about somebody gives a food place, a restaurant is given 4 stars. I like this one because I can accept a couple different things. Yeah, actually, let me do it like this, just to make it really clear. It's given this rating. That's the rating it's given. Yeah, what's star divided by star star? I don't freaking know. There's not, I'm trying to show you, if I would have said 4 stars, I would have accepted ordinal or ratio, because you could argue that, or even ratio would not be good. Why wouldn't it be ratio if I said 4 stars? Well, I guess I would accept ratio, because is there a 0? Yes. Yes, okay, good. So that would be, I would accept ratio then. So very often on a quiz, I'll say, what level is this? Explain your reasoning, because you're going to look at it 2 different ways, and I might take 2 different answers based on how you explain it to me. Are you with me? So you could say you're looking at the 4, and something got 4 stars, got twice as many stars as 2. Or you could say, no, I see that as like symbols, and there's an order. The 4 stars better than the 3 star. So I would take either ordinal or ratio, depending on how you describe that. Either one. I like it. You can think of it as non-numerical, just images of stars, or numerical, 4 is the thing you're looking at. That'll change what level it's at. All right. Understood? A little bit? Like some of you guys are like, don't tell them anything. All right. Don't give them any indication of how we feel. Let's see what else we got. What about political party affiliation? You know what that means? Like if you are a Democrat or a Constitution Party or a member of the Communist USA Party, which is there, or a member of the Green Party, or a member of your own party. Do you guys know how many candidates there are for presidency right now? No. Higher. 1,861. So part of what we're going to do next week is we're going to start looking at some political parties. You guys are going to be forming groups based on parties you want to investigate. I think they want to break this wall down, make the room bigger. I don't know if you heard that. But yes, there are 1,861 political candidates that vote going. When I looked this morning, some of them have names like King Jambo Satan is one of them. So some of them are fringe, to say the least. Right? But anyway, so we'll get into that later. So political party affiliation, what type of variable would that be? Nominal, totally, right? You wouldn't say that there's an order. I don't care if you say, well, Republicans come first. I don't care about your feelings. There's no inherent order to those words, right? So this is completely nominal. There's names, categorizations of your affiliation. That's it. So they're nominal. I love it. Don't let that kind of question be difficult. Right? Be able to distinguish between these four levels. Okay. So what we're going to do today is go back a bit and talk about selecting samples. We talked a little bit about random sampling, and we talked about the problems to be careful about, how to try to make it a random sample. What did we figure out was a good definition of random sampling?
Every person sampled has an equal chance of being sampled.
Everybody in the population, or everything in the population, has an equal chance to be in the sample. That sounds fair. That sounds like it would make a good sample, right? Or that's your best thing to do. So if I randomly picked, truly randomly, like took all gave everybody a number, put them in a hat and took the numbers out, is it possible that I can get nobody over the age of 20? If I took like 100 Grossmont students, is it possible that they would all be under the age of 20? Is it possible? Yes, because there's more than 100 people here at Grossmont that are under the age of 20. Is it likely? No, it's not likely. So I do everything in my power to make the sample representative. And what does representative mean, really? Well, it means it has about the same percentage of different groups in it. That's what representative means. So I do everything in my power to make that happen, but randomness says, sometimes you ain't going to get it. Too bad for you. So some randomly selected samples could actually be biased, but we don't know. But we do everything we can to make it as representative as we can. You guys semi with me here a little bit? But so let's get into the types of sampling, because there are some ways to control for some things and still have a random sampling. So this is types of sampling. How's he doing? Is he going to make it very far? He's still going. Look at him. All right, good. Sorry. I'm easily amused. So the first type you already talked about is the goal is a truly random sample. Everything or every person in the population has an equal chance of getting into the sample. That's random sampling. There are different ways to get there, though. So, which order I want to do this? Sure, let's start with this nice one. There's something called systematic sampling. And what does that sound like? What's the root word of that? I mean, system. There's some kind of a system to how I do things. So, if I wanted to see the average temperature over the course of a day, how could I do that? See if you guys say what I want you to say. Yes, sir.
Record the temperature like every set number of hours.
Beautiful. Like every, let's say every 30 minutes, I go out and take the temperature, and then I record it. Do you see how there's a system to it? Every 30 minutes. Or if a cop wants to see how fast people are going, maybe he'll sample every fifth car. He'll see how fast he's going and give you a little heart attack. I'm looking to pull you over. Oh, shit! All right. So that's systematic. It's nice. The root word tells you there's a system to it. Every 30 minutes, every fifth car, every fourth person, every sixth song on the radio. There's some kind of a system to it. What could be the downfall of this type of sampling? Every nth item or minute or blah, blah, blah. Right? What could be the downfall of that? Yes, sir.
You might end up just getting a few outliers.
Yes, what would cause that to happen, though? If you took every fifth item off an assembly line and you're looking to see what percentage of them are defective, and you get like 100% defective rate, what could that actually mean Like, what if there's a little, like an assembly line, I always have the old Charlie Chaplin view of it, where it's this thing that turns into ka-chunks, and then it turns into ka-chunks, and maybe the fifth ka-chunker goes ka-chink, and it's like, bleh. So if there's something in the system that happens every 5 times, and I sample every 5th one, I'm like, that's no good, that's no good, that's not, everything's crap, when everybody else is fine. So so I don't want to use this if there's a chance that there's something that happens every 5th time or something. Does that make sense? So I wouldn't want to use it on an assembly line because maybe I'm getting the one that relates to the bad part in the assembly line. But like doing every 30 minutes temperature, that's not going to be a problem. Every 30 minutes, right at 30 minutes, the temperature dips. No, I don't think that's going to happen, right? Oh my God, it's snowing, and then I go back inside, 90 degrees. No, it's not going to. Right? Do you guys get what I'm saying? So systematic in general is good. Why is it still random? So like, how would I do systematic with you guys? How would I do systematic with you? If I wanted to pick a sample of so many people, what could I do? Every third person. So 1, 2, 3, 1, 2, 3. So do you guys think that's random?
Yeah.
It is random, but that's not quite the right answer at the moment, because does she have a chance the way I did it? Does she have a chance to be in it? No, right? So one way to do it is to take the first person. Now, if I took the first person, then he has no chance, right? So what I do is I randomly take the first person, and then I take them, and then every third one after. So if I randomly select somebody in this row, I just blindfold myself, or I throw a dart and it sticks in your head. Oh, you! And then I take him and every third person after him. Then did everybody have a chance? This is where people get a little confused. Don't say, I pick you and not you, and then you go, well, you didn't pick him, so it's not random. That's silly. I'm not going to pick everybody for my sample, right? Did he have a chance? Yeah, he could have been the person I randomly selected, right? To start it off. So systematic is a type of random sampling, if you do it correctly, but there are situations where I don't want to use it. Are you guys understanding how this works? A little bit? Very honest look on your face. I like it. You're like, no. Do you understand how the process kind of works? The thing that's weird is, how do I start? And that's where I can make it truly random. I randomize the first person I pick, so then I don't automatically have built-in people I'm skipping. Like, you would never have a chance if I do it, sorry, you started you, and then I'm going to skip you. But if I randomly select the first person, there's a chance you're going to show up. That's all you need, is a fair chance. Then you're a truly random sample. All right. Maybe. Good. So that's systematic. It's really easy to identify. If I collected eel grass from the bottom of the bay every 40 feet, the every 40 feet part gives this away, right? That's systematic. I like it. What about these next two I'm going to have to do sort of together? There's stratified and cluster. Okay. They both start off the same, so it's really easy to confuse the two. I'm going to do what I can to make it clear which one's which. So they both say, break your population into groups. So for example, let's say my population was everybody who is on the campus of Grossmont in a classroom right now. So what are my groups then? Each classroom. So that's what I've represented. Maybe I have 3 classrooms currently that have students in it. Probably more, but I don't want to draw a lot of boxes, right? Somebody's sort of moving so far. So both of these say, break your population into groups. It could be by zip code. If you're at a high school, it could be sophomores, freshmen, juniors, seniors, right? Whatever. And this is how you can control making sure that every subgroup gets a say or is represented. You kind of with me? You can do it by race, you can do it by age, you can do it by whatever. So what this guy says next, though, is go to each classroom, go to every single classroom, and randomly select a few people. Those people will be in your sample. How are we doing so far? So I would take a few people from this classroom, randomly selected, do it by numbers or do it by throwing darts again, I like that. Woo, ouch, you. Woo, ouch, you. And then go to the next classroom, take a few people, and then go to the next classroom, take a few people. Did everybody in those 3 classrooms have a chance to be represented? Yes, of course they did, because I went to each one and then randomly picked people there. Good. We're golden? So it is an example of random sampling. Cluster says randomly pick some of your groups and then take everybody. So, close your eyes and, this one and this one there. Right? Randomly select groups and then take everybody. Everybody, and nobody from you. Nah, we don't like you, stay out. You guys understand? Is that an example of random sampling?
No, because...
Tell me who didn't have a chance from the beginning, who didn't have a chance to be in the sample? Nope, that was after I started. Remember, it's all about the chances. Once I pick, you can't complain. Before I pick, did everybody have a chance? There. Don't complain that, oh, look at your sample. You didn't have her in it. Well, I didn't have a lot of people because that's the whole idea. I want the sample to be smaller. But at the beginning, did everybody have a chance? I could have picked this classroom, right? Because I randomly picked. So everybody here had a chance. Everybody everywhere had a chance. It's another example of random sampling. How are we doing so far? Do you see how it's really easy to confuse these two? I always think about this. You know those cluster cereals? So when you put your spoon in, you're going to pick some clusters, but not others. I don't know. Does that help? I don't know. I'm trying. So you get whole clusters and not others. Is that going to help? There's also a little saying. You can say, some from each. All from some. You say, some from all from some. It sounds sort of like Musketeers going on, but some from all. To potato. I don't know. My Musketeers were sucking helium, I guess. Come on, guys. Does that make sense? So some from all, and the nice thing with that is it starts with an S. Some from all. Nobody gets left out, but no groups get left out, but you should take some from each group. This one is all from some. So some get left out entirely, but you take everything from others. All right. Now, a while back, real quick. Do I have any veterans in the class that were in Iraq, maybe even? No? Where were you? Were you in Afghanistan, or can I ask you? I don't know.
Well, I was in that area, but I was unsure.
Okay, gotcha. I was teaching this course in intercession, believe it or not, back when it was 3 units, a while back, and there was somebody who had been in Iraq, and he complained about this. He says, okay, this is bullshit. And then I had to go investigate because he told me something and I had to look it up. So what happened, real quick, they wanted to see how things were going around Baghdad after the fall of Baghdad, after it had been a little while, to see how people were recuperating. So they randomly broke it up into sections and supposedly randomly selected, so they were doing this. The problem is, this was a independent little research group that didn't have a lot of defensive power. So they picked the sections they knew were safe and then went in there. So is that truly random sampling? No, because they eliminated from the beginning the possibility of selecting. They eliminated some of them so that every section have a chance? No. So it's not cluster sampling that sucks. It was the use of it that sucked. They misused it. So all of these are completely valid. It's just you got to use them correctly, right? You guys kind of with me? I like that story because you got to separate the idiots that don't use stats correctly from the poor little stats that are like, leave me alone, just use me right. Okay. There's one more type that I purposely didn't put up here yet. And it's called convenience sampling. And it's exactly what it sounds like. From what it sounds like, do you think, and actually from my tone I'm giving it away, can I trust this kind of sampling? No. What does your gut tell you? Can somebody come up with a situation that might be convenience sampling? Let me give you one we've already had. If I wanted to know something about all Grossmont students, but I'm lazy, and I don't want to do like we said last time, come here all different times of the day, go to all different parts of the campus, talk to all different kinds of people. It's great. I got you guys. You're convenient. Let me sample. You got your gross bond students. What's the matter with that shit? So you would be a convenience sample. So that's an example of a convenience sample. It's convenient, so it's almost inherently not going to be random. You're not trying to make it representative. Does that make sense? Does that make sense? You guys with me? Some of you guys like, still, I don't want to play poker with a lot of you. Still, shit, nothing. Damn, yes.
So, are there ways to make convenient sampling more better? It's inherently...
If it's convenience sampling, it's bad. Because it means you didn't even put any work into it to try to make it. Now, is every single convenience sample you pick not representative? No, you could get lucky. But is there any way to know that that happened? No. Is every single random sample a great sample? No. But at least here you're trying to make it happen. You're allowing it to happen. This has a much higher chance of being good than this does. Right? Okay, and that's life. All we can do in life is control the probabilities. Right? If I want to control the probability that I live long, I exercise and I don't smoke and I don't drink a lot, just enough, and blah, blah, blah. Right? You with me? And I can still get run over by a bus. So, I mean, all you can ever control... Oh, that's such a nice view of life, Jeff. I'm good. I'm doing pretty good. I apologize if it happened. But do you guys know what I mean? We can only control the probability. That's why I love statistics. That's why people don't trust it, because it's so freaking honest. That's why I love it, though. It's very honest math. It says, you want to know the exact answer? I don't freaking know. Give or take 5%. Good luck. Right? I love it. All right. Let's see. Blah, 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 blah. So now I think I'm caught up to where I want to be. Yes. Yes. Cool. Blah, blah, blah. Blah, blah, blah. Blah, 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 blah. Okay. Blah. Okay. Do it. Sweet. Okay. So we've talked about types of sampling. We talked about types of variables. There's a few different ways, and I think I didn't talk about discrete and continuous. So I didn't talk about it in class. Somebody asked me a question about it. You can pretty much read about it, but let's talk about that real quick just to make this a complete thing here. I just forgot to talk about these. The word discrete is a little weird. Normally it implies like sneaking around or being careful. Be discreet. But that's not really what it means here. Continuous, you should have a better feel for. What does continuous mean? Does anybody know what continuous means? Like if I was drawing... Yeah, go ahead.
Without end. Without end.
Yeah, one way is like without end. It doesn't actually have to have no end.
Without a break.
Without a break. Exactly. Which some of you guys are like, that's my life. But... Right? So if I was drawing in algebra, this would be like this. There's no break in it. Whereas this has a break in it, right? You guys kind of see what I'm saying? Okay, all right. It doesn't exactly apply here, but it's the same sort of idea. So continuous variable can take on any value between two values. So if it said, how much does your backpack weigh? You probably wouldn't say 4.79344442667 pounds, right? If you did, I'd be like, whoa, you've exceeded my geekiness. That's good, right? You guys with me? You would say about 5 pounds, right? But that it's still continuous because if you wanted to, you could be very, very precise. Whereas if I said how many doors are on your car, would it make any sense to say there are 3.5496 doors on my car? I'm like, I gotta see your car. What does that mean? Every Thursday, every third Thursday, this door suddenly becomes not a door. What? No. Do you understand what I'm saying? So discrete would be like the number of blank, the number of TVs. You wouldn't say you got 4.5 TVs, even if one of them only works half the time. It is still a TV, right? Do you guys get the feel? So continuous normally is true measurements, like weighing something, measuring something, the length of something, right? Whereas discrete is counting stuff. the number of pages you can type, the number of words you can type, the number of people in a room, right? So this normally is like number of blank. And this is like weight, height, so forth. Now be very careful. I want you to understand. If I said I live 20 miles away from Grossmont, is that an example of discrete or continuous? I love it. Most of you guys said continuous. I know I said the number 20, but the whole idea is what could it be? Does it have to be a whole number? No. Maybe I actually live 19.4361, right? Do you guys understand? So don't look at the number I give you. Think about what it could be. I'm a human, a normal human, believe it or not. I'm not going to say I live 19.5625. No, right? I'm going to say 20 miles. Do you understand? It's all about what could the value be, right? Now, what's okay? Why is it okay to hear this? The average couple has 2.8 kids. Why is that okay? Kids, the number of kids should be what kind of variable? Pleased to God, right? But why is that still okay to say that the average number of kids is 2.8? Yeah, it's an average. So I divide by how many couples I'm looking at. So the number could come out anyway. It doesn't mean that somebody actually has a 0.8 kid. Here, right? Here's Jeff, and here's Dana, and here's... just the beginning of a... I'm sorry. I have this weird image. Something running down the stairs. I'm sorry. You're either a kid or you ain't, right? All right, sorry. Okay. Whew. So, stuff like averaging, when I actually do something with data, the number that comes out could be anything. But the actual variable is that the data itself, each data value for number of kids has to be a whole number, right? Pleased or God. Okay. All right. And to be honest, I am not going to talk too much about section 1.4. I'm going to let you guys have fun with that one. But I am going to talk about the last part of 1.3, which deals with stuff called relative frequency and cumulative frequency. Okay. So let's see. Before I forget, if you haven't done the surveys, I am going to send out a reminder email probably tomorrow and then again this weekend. Because next Monday I really want to have that data to look at, right? Data. But for right now, that was freaky. Let me see. Do I want to do this? Maybe. Sure. Why not? All right. You guys ready to play along? All right. Anybody uncomfortable telling me how old you are? Good. All right. Here we go. So tell me how old you are. How old are you? 18.
17.
Yeah. Good. Keep it going. 17. 18. 18. 18. Who is it? 19? Yay, new number.
24.
24.
17.
17. 18.
24.
24. 18.
19.
19.
18.
18.
40.
Where are we at? 40?
21.
Listen to you. It'll come. You don't 21? You don't want it. 21? All right. Look at that. We can go on, Trey.
19.
19? Legally.
17.
17. Not yet.
18.
18.
18.
18? 18? 19?
19.
19?
25.
25?
Yeah.
Be proud of it. Where are we at? 18?
17.
Did we get everybody back there?
No, 18.
Okay, 18. I'll come up here.
17.
17.
20.
20.
22.
Whoa, 22 and 18. Are the people sitting on somebody's lap? No? Did you go already?
22.
21.
21, what'd you say?
22.
22, okay. I think you said 42. I'm like, damn.
You already have the 22.
Oh, you already have the 22. That's why you were looking at me like that. Oh, you're the one sitting on his lap. Okay. 21,
26.
26, 18. Man, this is exciting.
17.
17, 20,
20.
20,
53.
53,
Yeah. 22.
22, 18, 18, 19, 18, 21, 24, 20. Oh, we already got you, right? You. Did you get you? Okay, you? Okay.
23.
23,
20.
20,
34.
34, 19,
22.
22,
20.
20, 23. I'll put myself up there. 43! Sweet. Can't believe it. All right. So, two things. I'm going to do one thing earlier than, well, we're going to sort of spill over into 2-1, I think, a little bit. But that's perfectly fine. Oh, yeah, perfect. This is perfect. We're going to do two different things. We're going to use something from 2-1 to help us order this really quickly. Next week, we're going to get into using the graphing calculator. So if you don't have one yet, you want to get one soon. I'm going to